going to make a few comments about question 2b from Guided Practice 8. It says, for all A, B, C in P of U, if A is a subset of C and B is a subset of C, then A union B is a subset of C. As usual, you should read from left to right, writing the appropriate statement as you go. I've just finished reading what this thing actually says to you, but that's not what I mean by writing the appropriate statement as you go. I mean to say, when you're writing the proof of this statement, you should write the appropriate statement as you go. So the proof of the statement should begin by looking at that, and when you write a proof of something that looks like that, you should begin by saying, let A, B, and C be subsets of U. Assuming we're giving a direct proof, you should then assume your hypothesis, which says, suppose A is a subset of B and suppose A is a subset of C and B is a subset of C. And once you have assumed your hypothesis, you should then try to deduce from the hypothesis that the conclusion is true. You should try to prove that A union B is a subset of C. In order to do that, you need to think about what is the working definition of this statement. And the working definition of this statement is this one here. So how would you write a proof of something that looks like that? Because that's your task. Your task now is to write a proof of this statement. And to do that, you just read it from left to right. You say, let X be an element of U. Suppose X is in the union, and you try to deduce that X is in C. But to say that X is an element of A union B, you need the working definition of that. It's worth writing that down next in the proof. It means that X is either in A or X is in B. Now that means that you've got two cases to consider. And until you consider those cases, you really don't know where X is. So case one would be, suppose X is an element of A. And then from that case, you would try to deduce that X is an element of C. And then you'd start over, you'd say, well, now suppose X is an element of B. And again, you would try to deduce that X is an element of C. But until you finish doing both of those cases, you won't have the right to tell me that A union B is a subset of C. In other words, after you finish case one, where you've shown that when X is in A, then X has to be in C, you don't have the right to say A union B is a subset of C in this case. Because the statement that A union B is a subset of C is this entire statement here. It has to work for every X in U. In other words, it has to work for both cases. So you have to reserve the statement that A union B is a subset of C until you've finished both of those cases. So that's the overview of the proof. And whenever I read a proof, I always look at the overview of it to see if it's present in your writing before I actually go into the details of it. So I'm looking to see that you've given me an A, B, and a C. I look to see that you've assumed that the hypothesis is true. I look to see that you're making an effort to deduce that the conclusion is true. And then I'm looking to see that you're using the right working definitions in order to prove that conclusion. In other words, that you're actually doing this. And so the next thing that I would look for would be to see if you've given yourself an X in the universe, you've assumed that X is in A union B by using the working definition of that, and then you've tried to deduce that X is in C. And after I see that that skeleton is in place, then I go back and I see what are the details that you've written in order to do all of those things. So put your video on pause and see if you can write up the proof using the skeleton that I've suggested, and when you come back, we'll compare our answers. Okay, so here's the proof, and as you can see, it's really very short. It doesn't take a lot to do it, but let's see if I've really done it. Before we look at the details, let's see if I've done what I've suggested. I began by giving myself 3 sets. I assumed my hypothesis here. I've told you what I'm intending to do. I'm trying to deduce the conclusion is true. And how do I do that? I look at the working definition. So this is actually a conditional statement. So here's the skeleton of the proof of my conditional statement. I give myself an X in the universe. I suppose it's in the union. And what I'm looking for next is to see that I've deduced that X is actually in C. So in case 1, I've said X is in C. In case 2, I've shown X is in C. So that means that I've carried out the full working definition of what it would mean to prove that A union B is a subset of C. And therefore, I have the right to say this. And once I do say that, I've deduced my conclusion, and therefore the proof is over. Okay, so let's look at the details. Let A, B, and C be subsets of U. That comes from here. Suppose A is a subset of C and B is a subset of C. Now I warn the reader that I'm going to try to prove that my conclusion is true. So I say we now show that A union B is a subset of C. So what do I do about that? I give myself an X in the universe. I assume that it's in A union B, so suppose X is in A union B, and that means that X is either in A or X is in B. And so I consider the two cases separately. And you notice I do that in a single sentence with the use of this semicolon. I say, in case 1, I say, if X is in A, then since A is a subset of C, by this assumption here, it follows X is in C. If, on the other hand, X is in B, so I'm telling you what the second case would be, then since B is a subset of C, it follows that X is an element of C. So now in both cases, I've shown that the X is an element of C, and therefore I have the right now finally to say that A union B is a subset of C. This completes the proof. Very short proof, but I've really done everything that I needed to do. I haven't left out a single detail, and yet it didn't take me a lot of words in order to achieve that. So that's something for you to try to strive to do.